Right, in this video, we're going to talk about suggested homework problems from 9.7. The topic here is Taylor polynomials and approximations. Let's go ahead and get started with number 1. The topic here is polynomial approximation. An elementary function is approximated by a polynomial. And in your own words, describe what is meant by saying that the polynomial is expanded about C or centered at C. So that means that the graphs of the nth degree polynomial that I'm using for approximation and f both pass through the point C f of C, and f prime of C Pn prime of C is equal to f prime of C, Pn double prime C is equal to f double prime C dot 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 P n nth derivative of C is equal to f n of C. So the first n derivatives of the polynomial approximation and the original function are equal at C. This allows Pn of x to closely approximate f of x at values near C. Okay, so let's look now at number 11. Number 11 says f of x is equal to secant x, and we're given a C value of pi over 6, and we're asked to find P1, the linear approximation of this. So I only need to find a first derivative, f prime of x. The derivative of secant is secant x tangent x. Let's just write f of x down here again, so that I can come over here and say f of pi over 6 is secant pi over 6 is equal to 2 over root 3, which I'll multiply by root 3 over root 3, is equal to 2 root 3 over 3. And f prime of pi over 6 is going to be, we already just found secant of that, 2 root 3 over 3 times, and then tangent is going to be 1 over root 3. So the root 3's will cancel and give me 2/3. So this is going to be P1 of x minus y value to root 3 over 3 is equal to 2/3 for my slope. X minus pi over 6 is p of x is 2x over 3 plus 2 root 3 over 3 minus pi over 3. I could instead write this as mx plus b, with being centered at x minus 6. This could be 2/3 of x minus pi over 6 plus 2 root 3 over 3. Let's look at number 17. Instructions for 17 say to find a Maclaurin polynomial for the given n value. Maclaurin polynomials are going to be centered at 0. So 17 says f of x is equal to e to the 4x. N equals 4. So f of x is equal to e to the 4x. F of 0 is 1. F prime of x is 4 e to the 4x, and f prime of 0 is 4. F double prime of x is 16 e to the 4x. F double prime of 0 is 16. F triple prime of x is equal to 64 e to the 4x. F triple prime of 0 is 64. F quadruple prime x is equal to 256 e to the 4x. So f quadruple prime of 0 is equal to 256. And then to write that polynomial, we're going to write 1x to the 0 plus 4x to the first over 1 factorial. This is over 0 factorial over 1 factorial. This is 16x to the second over 2 factorial. Plus 64x to the third over 3 factorial plus 256x to the fourth over 4 factorial. F of x is approximately this. So 1 over 0 factorial is 1, so 1 over 1 is 1. Plus 4 over 1 is 4. 16 over 2 is 8. 64 over 6 is 32 over 3. 256 over 24 can be 8 goes into here 3 times, 8 goes into there 32 times. That's also 32 over 3, x to the fourth. Look now at number 25. F of x is equal to secant x, n equals 2. So f prime of x is equal to secant x tangent x. Have f of 0, secant of 0 is 1, f prime of 0 is 0, f double prime is derivative of secant is secant tangent plus derivative of tangent is secant squared. Double prime of 0 will be 0 plus 1 is 1. So this will be 1 plus 1x squared over 2 factorial is equal to 1 plus 1 half x squared for my P2 of x. Number 29. F of x is equal to the square root of x. N is equal to 2. C is equal to 4. F prime of x is equal to 1 over 2 root x. F of 4 is 2. F prime of 4 is 1 over 2 times 2 is 1 over 4. F double prime of x, this is 1 half x to the negative 1 half. So this is negative 1/4 x to the negative 3 halves. Negative 1 over 4 x root x. F double prime of 4 is 16 times 2 is 32. It's negative 1 over 32. So we're going to have f of x, which is going to be p sub 2 of x is equal to 2 plus 1/4 times x minus 4 minus 1 over 32 times x minus 4 squared over 2 factorial. This is over 1 factorial. This is over 0 factorial. So e2 of x is 2 plus 1/4 x minus 4 minus 1 over 64 x minus 4 squared. All right, let's go ahead and let's look at number 39. Approximate the function. So f of x is equal to e to the 4x. We want to approximate f of 1/4. We did do number 17 earlier, where f of x was approximately equal to 1 plus 4x plus 8x squared plus 32 thirds x cubed plus 32 thirds x to the fourth. Using the answer from number 17, we want to approximate f of 1/4. So that's approximately 1 plus 1 plus 1/2 plus 1/6 plus 3 times 1/4. 4 goes into here 8 times. 4 goes into there 2 times. 2 goes into there 2 times. 6 times 4 is 24. So f of 1/4 is approximately 24 plus 24 plus 12 plus 4 plus 6 times 4. That's 1. And this is all over 24. 48, 64, 65 over 24. And 65 over 24 is approximately 2.7083. And there's my decimal approximation of my answer. And number 47. 47 says that the hyperbolic sine of 2/10 is approximately 2/10 plus 2/10 cubed over 3 factorial plus 2/10 to the 5th over 5 factorial. So this is an odd function since I have only the odd powers represented. And we want to know what the upper bound for the error of the approximation is. So I have to go one more term here to f6. 6 derivative f x is sinh x, so f1 is cosh, and 2 is sinh, and back and forth, so that every even power is sinh, and every odd power is cosh. So f6 x is equal to sinh x sinh is going to be an increasing function like this. So on the interval from 0 to 0.2, its maximum value is at 0.2, sinh of 0.2, whatever that is. So my remainder needs to be less than or equal to 0.2 to the 6th over 6 factorial times the hyperbolic sine of 0.2, 0.2 to the 6th times catalog hyperbolic sine of 0.2 divided by 6 factorial. This answer is approximately 1.7. Let's call this 1.8 times 10 to the negative 8th. My exact error is going to be the absolute value of sinh 0.2 minus 0.2 plus 0.2 cubed over 6 plus 0.2 to the 5th over 120. So that's going to be hyperbolic sine of 0.2 minus open parenthesis. Let's do absolute value around this. Mode, let's turn that print off. So I want absolute value of hyperbolic sine of 0.2 minus 0.2 plus 0.2 raised to the third divided by 6 plus 0.2 raised to the 5th over 120. Close my parenthesis there. Close my parenthesis for this. And this is going to be approximately 2.5 times 10 to the negative 6th for my solution. Negative 6. Absolute value of sine minus 0.2 plus 0.2 cubed over 3 factorial is 6 plus 0.2 to the 5th over that's supposed to be 1250. That's 5 factorial is 120. There we go. So that's 2.5 times 10 to the negative ninth. That was just a typo typing it into the calculator. Hopefully you caught that before I did. And that's it for this video. We'll come back next time and talk about section 9.8, which is Maclaurin, I'm sorry, it's power series. So we'll talk about power series and how they're different than these Taylor and Maclaurin polynomial approximations. Next time, a power series will be an exact representation of the function f of x and has an infinite amount of terms to it. So see you for the next video.